Okay, good morning. How is everyone? Good. Hope you guys had a great weekend. It's good to see you. So ask that you put your video on if you can at all possible. It really helps me to be able to see your faces. So yay, we're in the last week of class. That's so exciting. You are done with all of your quizzes, done 8 homeworks. You probably saw that I did put 2 additional homeworks up. I highly encourage you to do those homeworks. They will not hurt you. So if you do better, on those extra homeworks than you did on a previous homework, it will replace it. If you do worse, it won't hurt you. So I highly encourage you to do it. So what I'm going to be doing is dropping the 2 lowest scores. So it means if you don't do those 2 extras, you'll just get zeros on them and they'll be dropped. So you'll just, have the 8 that you did. But if you did better on one of the 2 extra ones, it'll drop out one of your previous homeworks that were lower, that had a lower score. So like I said, it can't hurt you, and it can actually help you because the assessment 9 has questions on there about regression and correlation, t-tests, and ANOVA. So hopefully it could help you get a little bit more practice with those inferential tests. And then the very last extra homework, it just gives you scenarios and asks you which inferential tests you would do. So if you're looking for relationship, you would be doing correlation. If you're looking for prediction, you would be doing regression. If you're looking for the difference between 2 groups, you would be doing t-test, or the difference between 3 or more groups, you would be doing ANOVA. So we'll give you those research scenarios, and you'll need to kind of work out in your head, like, oh, which one of those inferential tests would I be using? And I think it actually has you differentiate between a dependent t-test and an independent t-test also, whether it's a between or a within measure. Okay, so I really highly encourage you to do those. It'll help you prepare for the final. The other thing you can do that will help you prepare for the final is I do have a final review sheet, and that's on Blackboard under Module 4. Under the tab for the final. So this gives you all the concepts that you'll be seeing on the final. And I will offer to you, like, I really encourage you to go through and answer these questions. Make yourself, like, maybe get some little flashcards or something where you can have the question, what is probability, why is it important, and then you have the answer on the back, and you can kind of test yourself. And I'm also going to give you 2 extra points if you fill this out and you email it to me before you take the final. Okay, or if you've already taken the final, you can still fill it out and email it to me, and you'll get 2 extra points. Okay, because I know a couple of people have already taken it. So if you fill this out and send it to me, you can get 2 extra points. The other thing you can do for 2 extra points on the final, so you can get a maximum of 4 additional points, is to do your course evaluation. So you can get on and do your course eval. I do ask you to give me feedback about what was helpful for the course, what could have been helpful, what could have made a difference to help you. I know that I really have to commend all the hard work that you guys have been doing. It is not hard. I mean, it's not easy to do a class such as this remotely. So I want to commend you for showing up, for engaging, for listening, for watching the videos, for working hard, because when you're all capable. I mean, math might not be your favorite thing, but you're all capable of doing it. And so it all depends on how much work you're willing to put into it. So I just really want to commend all of you for putting work into it and continuing to try and put effort, because that's what it takes to have success, is just to continually put effort in. You know, when, you know, it's like in general, when we get knocked down, we just got to get back up again. You get knocked down, you get back up again. And so that's valid for anything in our lives, but specifically for academics. If we don't do as well as we'd like, then we just got to get back up and review and keep learning and growing and figuring out what we can do different. So I just want to commend you guys for doing that. I really appreciate it. So if you get this final review thing done, please, you know, answer the questions and then send it on into me, but that'll help you review for the final. There are 40 multiple choice questions on the final, and it's worth 20% of your grade. And it is, you know, it's very challenging. It's a challenging assessment. So you've got to make sure you prepare for it. And it's kind of an overview of what we've done for the semester, and just trying to ask you questions that would show your ability to apply those concepts to problems. Okay. Always feel free to reach out if you're still struggling with the concept. If there's still a concept that you're like, I'm still struggling with that, when I get on to Excel and I'm doing things, I'm still struggling with it, reach out. We can spend 10 minutes on Zoom just going through how to do that calculation, how to interpret it, how to apply the knowledge. I'm more than happy to do that, okay? I want to help you. The more practice you get, the easier it's going to get, okay? And so with that, I did notice, I was kind of surprised that only 4 of you guys did the extra credit for the midterm, but that was totally up to you. It wasn't required. But I am going to go through that right now, just as again, another practice. So these were the scores on the midterm. And so I had asked you to tell me the mean, median, and mode. So what you would do for that is you would go to data analysis and you would do some descriptive statistics on this group of data. And then I'm going to put that, let's see, I'll put that in C1. Okay, so the first answer to the first question on the extra credit, the mean was 80. The median was 78 because it's the very center score. I gave them to you in, I think I gave them to you in order. So you should have put those into Excel. They were right in order. So we can go to the 5th score. So the median's a 78. The mode, this was actually a bimodal distribution. It had a mode of 78 and a mode of 90. Okay, so it would be considered bimodal because 78 occurred twice, but so did 90. The standard deviation was 12.3 basically. So those were that was the answer to the first question. The second question asked you to, I think it asked you to calculate your z-score. So what you would have done is you would have taken your raw score. So you could have just done a calculation right in the cell, equals your raw score, which is whoops, I'm going to put this in parentheses, which is A1, are the raw, or where the raw scores are. So A1 minus the mean of 80, and then divide by the standard deviation of 12.3. Okay, so that would give you the z-scores. Okay, so you can see whatever your score was over here, you should be able to see your z-score over here. Okay, easily calculated. The raw score minus the mean divided by the standard deviation is a z-score. And then we can put these z-scores on the normal distribution. Okay, so can you guys still see it? Okay, so if I've got a normal distribution, we know that if we want to do the percentile, I mean, we can look at the z table, but we also know that that's the 50th percentile. We know that if we add the 2.5 and the 13.5, this is the 16th percentile, this is the 84th percentile, this is the 2.5th percentile, and this is the 97.5 percentile. Okay, so it gives you a little bit of an idea where your percentile is just based on the z-scale, where the mean is 0 and the standard deviation is 1. If we're just going to the 95th confidence level. Okay, so if somebody had a z-score of say just that first one, negative 1.6, we'd go to negative 1.5, negative 1.6. Okay, so we know that person falls right here, and they could kind of guess what their percentile is. It's the 2.5 plus a little bit of this 13.5. But a better way to do that, to know exactly where you're at, is to look up the negative z table online, and if we look up the negative z table, all I did was Google negative z table, and it brought this up. So I'd go to negative 1.65. So I'd go to the negative 1.6, and then I go over to the 0.5, and I would find out that that person's at the just about the 5th percentile. Okay, just about the 5th percentile. So then the next one was a negative 0.65. So I'd go to the negative 0.6, 1, 2, 3, 4, 5, and I find out that that person's about at the 26th percentile. Negative 0.65. Then the next one was negative 0.49. So I would go back to the z table, and I'd go to negative 0.49, and I'd find out that they were at about the 31st percentile. Okay, you guys get how to read the z table? So that's what you should have done, is you should have gone to you should have figured out your z-score and then gone to the z table, whether you were at the positive or the negative here. I'll do one of the positive ones. So one of the positive ones was two people scored 0.81. So I'd go to 0.81 and I find out that they were at the 79th percentile. Okay. So that would have been your answer to what percentile do you fall. Okay. Then I also asked, we'll go back to the distribution of scores. Then I also asked, I think, what was the 95th percentile range of scores? What were the range of scores you would find? So that would have been the mean. You would take the mean, which was 80, plus or minus 2 times the standard deviation, which was 12.3. So we would have taken 80 minus 12.3 minus 12.3 for the 2 standard deviations. And we would have found out on one side, it was 55.4. And then we would have added the standard deviation twice. 12.3 plus 12.3, and we would find out on the other side. Okay, so this one equates with the other side was 104.6, which equates with that second standard deviation. So the range of scores for the 95th confidence level was on the one side of the standard, the normal curve, 55.4. And on the other side, 104.6. So 95% of the scores would fall between 55.4 and 104.6. If we were using you as a sample of, say, all students in health science and human movement. Okay, we would expect 95% of the scores on this exam to fall between those two scores. Okay. And then I asked you to let me know what would be an unusual score. And so you would have picked a score either below 55.4 or above 104.6. So most of you picked a score below 55.4. You said like maybe 50. 50 would be considered unusual. It wouldn't be somebody from this population. Okay, that's not what we would expect. Okay, questions about how to just quickly go in with a array of scores. You know, we've got an array of 9 scores. How you would go in and calculate this. Anybody questions? It's fairly straightforward. But again, I would want you, if you're still struggling with that, how do I find the percentile? Because some of you that did the extra credit, you didn't get the right answers. Okay, so you may have forgotten to do 2 times the standard deviation for the range. That's a common mistake that people make. Remember, you've got to add the standard deviation for one and then 2, and then subtract it 1 and 2. Some of you maybe weren't reading the Z table correctly. So if you're still struggling with that, go back and kind of practice that a little bit, or reach out to me and I can help you. Okay. Okay. Any questions about that? Okay. So if we had another array of data, so I'm going to do, let's say I'm going to do, I'm just going to guess to see what the grades on the final will be. Okay, so I'll just do a guess. Oh, I want to do them in order again. me change this. Okay, so now we have two arrays of data. This is the midterm and this is the final. Okay, so if I wanted to go in and do a comparison of them, let me first get rid of this. Okay, if I wanted to go in, if I wanted to see how much they were related, if I wanted to see if there was a relationship between the two arrays of data, then what inferential test would I do if I wanted to see if there was a relationship? Rachel?
Correlation.
Very good. So if I want to see if there's a relationship, I'm going to run a correlation. So I'm going to go to data analysis. I'm going to go to correlation. I'm going to put in my two arrays of data. Whoops, I'm still in my draw function. Got to get out of that. What are you seeing? Are you guys seeing the Excel? Oh, okay, good. I just want to make sure you still weren't seeing the data table. Okay. Hang on, let me just get out of that because it still was in my draw function. Ah, get out. How do I get out of this? It's like stuff gets behind other things and I'm trying to get out of it. Sorry. Okay. Okay, I finally got it dealt with. Okay, so I'm going to go in. I'm going to do correlation. Ah, why isn't it getting me out of that? I'm sorry, you guys. Some days I'm just struggle more than others. Maybe my pen will get me out of it. This is pathetic. Because I can't, the pen function like that it went away. Like it got closed. Now I should be able to get rid of all of these and select that. Okay. Okay, finally. I'm so sorry. Okay, so then I'm going to see if there's a correlation. So I'm going to put this in G1. Okay, so I ran a correlation. So what do you guys think? Is this a high enough correlation for me to say that I would run a prediction equation? What do you guys think? What do I need? What would you feel good about to be able to say, yeah, I think I should run a regression? What kind of correlation should I have?
Above a 90?
Yeah, so really, like, even if it's above a 70, like if it's a 90 or above, for sure, you're going to run a, you're going to say, this is strong enough for me to do a prediction equation, okay? But if it was even above 0.7, I usually feel like there's probably some strength. And if you have a really large data set, you can even see a significant correlation, you know, statistically significant, even down below 0.7. But then you always have to look at error. If the error rate is really, really high, then, you know, that's where that balance is. You're looking at the correlation versus the error. And the lower the correlation, the higher the error is going to be. And, you know, when you're getting around 0.7, that's where you kind of get to the point where like the error is too big, even if it's a significant correlation, okay? But since it's 0.96, what we're going to do is we're going to say, yeah, let's run a regression, okay? Let's run a regression because that's a good high correlation. So I would go into my data analysis. I would go to my regression, okay? And what I'm probably going to be doing, I already have my midterm scores. So I would be trying to predict my final scores, okay? So when I do a regression, I'm trying to predict possibly my final from my midterm, okay? So the final scores are going to be here. Why is this doing this? So bizarre. Okay, so if I'm trying to use my like my thing has not been doing this before. I do not know why this is happening. It's like my my pen thing went away, so I don't have control over it anymore. Like usually there's a thing that comes up on the screen for me where I can either use my pen or get rid of it.
Try clicking on the Draw tab at the top of the screen.
Yeah, but see, I'm just drawing right on this. You see what
Is
I'm
it
saying?
Yeah.
Let me put this down here and see. if I can. Maybe it's down. I don't know. I've never had this happen to me before. Like usually there's just a, like a, where I can control the pen, there's another window, and then I can just turn it off. It's like it's in like some kind of stuck mode.
Try clicking off of where it says format, because the drawing tool is right above format.
Okay, I think I might have figured it out now. Okay, let me see if I can do it now. So if I go into, but it's like won't even let me erase this stuff anymore. It's very bizarre. I don't know if something's going on with my pen or, okay, but I think I finally got it kind of turned off. Okay, so if I go into data analysis and I do regression, okay, so I'm trying to predict the final, okay, from the midterm. So I'm going to grab the final for the Y scores, and I'm going to grab the midterm for the independent variable. So whenever you're running regression, you have to figure out, what do you want to be predicting? Okay, what do you want to be predicting? And that's going to be your Y score. Okay, so you're going to use your thing that either you don't have or it's harder to get. Okay, so whatever you want to predict is something you don't have yet, or it's something like it's in the future, or it's something that's harder to measure. So like we've used skin folds to try to predict body fat because skin folds are easier than doing like MRI or something, okay? So it's like, what do we want to predict into the future, okay? So I'm gonna then put this in J1.
I'm sorry, did you pause your screen sharing? Because I don't think we're seeing
Oh,
regression.
I'm so sorry. Okay, can you see it now?
Yes, thank you.
Okay, thank you for letting me know. Okay, so remember, you would go into data analysis, you would go to regression, you're going to pull the data that you're trying to predict. That's the Y. Okay, so the Y variable is your dependent variable. It's what you're trying to predict. And that would be something in the future, or it'd be something you don't have yet, or it'd be something that's harder to measure. And that's going to be the other column, the X range, is the independent variable that we already have, or that's easier to get. Okay, and then once we have the ranges in there, then we would go ahead and run the regression, okay? So the output, the summary output for the regression, we already knew that it had a correlation of 0.96. But then we can drop down and we can tell, well, is that a significant correlation? So remember when it says e to the negative 0.05, that means that you're going to take your decimal point and put it 5 spaces. So we'd have a 0.4038. So 0.000038. So is that less than 0.05? Absolutely yes. So we know that there's a difference. Okay, we know that we know that there's a significant correlation. So we know that there's a significant correlation here, 0.96. It's very high. Okay, so we can do a regression equation here. Okay, so we could do the y equals mx plus b. Okay, so we could say, okay, we want to predict with y. Okay, so we've got our y would be, if I wanted to predict what somebody was gonna get on the final, then I could use the slope. Okay, remember the slope is with the x variable. Okay, so 0.81 times their midterm score. whatever they got on the midterm, plus the intercept, and the intercept is 12.86. 12. Let's just say 12.9. Okay, so this would be my regression equation. Okay, so then I could plug someone's midterm score in and I could predict what they would get on the final. Okay, so for instance, if somebody had gotten a 90% on the final, on the midterm, I would do 0.81 times 90, and then I would add the 12.9. So I would predict that they would get about an 86% if they had gotten a 90 on the midterm. Okay? Questions? Okay, I can also do a confidence interval on this because I can look at the standard error is about 3.08 or 3.1, so it's about 3. So I could do, if I knew what the average was, which I did, I knew what the average of the midterm, but let me figure the average of the final real quick. Okay, so the average of the final is about 78. So if I wanted to predict the error on the final, I could do 78 plus the error times 2, and the error was 3. So remember, the error was about 3. I've got to do it 2 times for one for each standard deviation. So I would plus 2 times, so that'd be 6, right? 3, add 3, and then add 3. So I'm gonna, so 78 plus 6 is 84. So I've got 84 on one side, and then I'm gonna do 78 minus 6. So I'm minusing 3, and then I'm minusing 3 again for the 2 standard deviations. And that is equal to 72. So my range, my confidence range is a 72 to an 84. Okay? A 72 to an 84 is my confidence interval. Okie doke? Makes sense? That's my error confidence interval at the 95% level. Okay, you guys got that? And that would be for the means. Like I've got a mean of 78 here. So I could say what mean would be different. I use the standard error right here. And I would say, let's say I pulled another sample of health science and human movement students. I would expect their mean on the final to be somewhere between 72 and 84. So like I would expect that the mean that you guys would get on this final, the mean of the scores would be somewhere between 72 and 84. Okay, so I'm using that to kind of make predictions. If a group sample got less than 72 on their mean or higher than 84 on their mean, I would then propose that they're different from regular health science human movement students. That'd be a different group. They came from a different population. Okay? Questions?
So you use the standard error when you're looking at a sample, correct? When you're trying to determine the confidence level?
Right, so when I use a standard error, though, I'm looking at sample means, not raw scores.
Okay.
Okay, does that make sense?
Yes.
So whenever I use a standard error, I'm always looking at sample means. So if I pulled another sample of 9 students, of health science human movement students, I would expect their mean to fall 95% of the time. Their mean would fall between 72 and 84. But remember, when you use a standard error for that confidence interval, you're looking at sample means, not raw scores. What would you use for a raw score?
The standard deviation.
Correct. So if I wanted to look at a raw score, I would need to come back to just the descriptive statistics. So I would need to do some descriptive statistics on the final, which I hadn't done yet. You know, I could do that quick. I could do some descriptive statistics on the final score, just so we could see what the standard deviation was on the final. Come on. Let me pull those. And then I want to put those, say, in C18. Okay, so for the final, the mean was 77.8, or just about 78, and the standard deviation was 10.4, right? So then I could say my range of scores for the final would be the 78 minus the standard deviation times 2, so that's 20.8. So 78 minus 20.8 equals 57.2. So the low end would be 57.2, and then the high end would be 78, plus the standard deviation times 2, which is 20.8. So the high would be, what, 98.8. So I would expect 95% of the scorers on the final to fall between 57 and 99. Okay, is that making sense? You guys seeing that? Remember,
So
whenever
if
you get the pardon, go ahead.
I'm just gonna say, so when you hear error confidence interval, you do the standard error, and when you hear range, you usually use the standard deviation?
No, well, here's the key word. If I'm asking if a raw score is different, you're going to use the standard deviation. If I'm asking if a sample mean is different, you're going to use the standard error. Okay, so if I say, is this score different? You would use the standard deviation. If I say, is this mean different? You would use the standard error. Okay? Because remember, the raw scores are they can fall on that distribution, but you're gonna look specifically at how each score deviates from the mean. But then when we're looking at comparing two groups, we're gonna be looking at their means, not at raw scores anymore. We're looking at their averages, right? So if I have two or more groups and I'm looking at their averages, then I need to look at the standard error. The standard error measures how much the means differentiate from the mean of the means. So remember when I talked about pulling like 10 or 20 samples and then comparing all of their means, we find an average of their means, and then we find a standard deviation of their means. That standard deviation is called the standard error. Okay? Okay, so you guys getting that? Okay? The other thing we could do is we could look and see, are those two significantly different? Was the midterm significantly different from the final? So if I wanted to do that, if I wanted to see, was the midterm significantly different from the final, what inferential test would I use?
Would it be a t-test?
Very good, Sierra. And what kind of t-test would I do? Because this is one group and I've got their midterm and then their final. So one group with 2 measures. What kind of t-test would I be doing?
A dependent.
Very good. A dependent, which is a within measure. Okay, so I'm going to run a dependent t-test. So I'm going to go in and I'm going to find the dependent paired. Remember the dependent is the paired 2-sample mean. Okay, my variable 1 is here. My variable 2 is here. I'm going to put this in N1. Okay, so I said, is there any difference between the two? So if I said if there's any difference, would I run a 1-tailed or a 2-tailed? Would I look at the 1-tailed result or the 2-tailed? If I'm saying any difference. Two-tailed. But what if I said, I think the final will be significantly lower than the midterm? Then what would I run? Or what if I said significantly higher? Still 1. So remember, if I do an alternative hypothesis and I say it's going to be either higher or lower, then I look at the 1-tailed results. If I say there'll be no difference, then I'm going to look at the 2-tailed results. So I said, let's see that if there's any difference at all, either upper or lower. Okay, so I'm going to look at the 2-tailed results. Okay, so I go to my probability level. My probability is 0.12. Is that less than 0.05? No. Okay. Remember, 12% is not lower than 0.05%. Okay. So 0.12 is larger than 0.05. So there's no difference between the midterm and the final. Okay. I'm also seeing that my calculated t is smaller than my critical t. It needs to be larger if there's a difference. So I know there's no difference, and there wasn't even a difference at a 1-tailed test either. So there's no difference between the midterm and the final in this for this array of data. Okay, so it's comparing these 2 means, the 80 and the 77.8. But remember, in order to read the results, you're going to come down, look at whether you want a 1-tailed or a 2-tailed, depending on what kind of hypothesis you had. Then you're going to look at the probability value, see if it's less than 0.05. 0.12 is not less than 0.05. 0.06 is not less than 0.05. There is no difference. You can also look at the calculated t-statistic, which is a 1.71. And you can see, is that smaller or larger than the critical of 2.3? Okay, if it's smaller, then there's no difference. If it's larger, then there is a difference. Okay, so you need to practice reading those too. So go back and redo those homeworks. If you're still struggling with regression and correlation, go back and redo practice homework 6 and then look at the answers and see if you're getting the answers. And then that homework 9 that I just put up, it's just what we just did. I've got some data in there and it asks you to do a correlation and a regression and read that, and then it asks you to do a t-test, and it actually asks you to do an ANOVA. It asks you to sort the data into 3 groups and then do an ANOVA. So remember, here's one thing about the ANOVA. When you sort, you have to actually put them in columns right next to each other. So if I had a data set where I had given you on that data set, I give you high risk, medium risk, and low risk population for heart disease. And so the data is all in one, well, let me just bring it up. Let me stop the share on this. So if I if I, I'm pretty sure I have that right in here. Yeah. Okay. So okay, so I've got males and females, and I ask you to sort them by male and female to tell me like if one was higher than the other at post-stress. But I also ask you to sort by their disease risk. So remember, whenever you sort, you have to grab the whole group. We're going to sort by their heart disease risk. Okay, so now I've got the high, the low, and the medium. It just does that because it goes alphabetically. But in order for me to do an ANOVA, I have to get all that data in columns. So I was looking at post-stress. So I would take the post-stress scores for the highs. Whoops. The post-stress for the highs. So I just grab the highs, copy those, and paste them over here. And then I get the post-stress for the mediums. I'm going to do the mediums next. I would get the post-stress for the mediums. Grab the post-stress for the mediums, copy those, put them over here. And then I would get the post-stress for the lows. I kind of like having them in order. Copy those and put them over here. Okay. ANOVA doesn't require you to have equal numbers in each group. So this is okay if there's a little bit difference in numbers. Okay. There are some things you run, you have to have equal numbers, but ANOVA will do this. So when you do the ANOVA, when you run the ANOVA, we're just going to do a single factor. You just have to grab this whole input range. Okay. And then tell it, and then tell it where to put it. Okay. Then you would have to read the results. Okay. So if I tell it to put it in M1, whoops, M1. Okay. Then I'm going to get an output like this. It looks at my averages for each column. Okay. So these are my stress scores at post. This is my average for the high risk, my average for the medium risk, and my average for the low risk. Okay. Then I would have to come down and look at my p-value to see if it's significant. If it was significant, then I would run a post hoc test, and then you would get the number for that post hoc test, which I do end up giving you if you feel like it's significant, and then you would have to see where the difference lies. Okay, but I just wanted to go over this to make sure you understand that you have to get these into columns before you do them. Okay, so I highly encourage you to do that, that last homework 9. If you already did it and you did the ANOVA wrong because you just didn't know how to do it, let me know and I'll give you another shot at it, okay? Okay, so any questions about the final or about the extra homeworks, or about anything right now that's popping up about what things you've learned in this class before we move on? Okay, if you do think of something that you want to just ask me about, again, I'm always here. please reach out. Please let me know what you're struggling with, okay? So the next item I want to talk about is the research project. So we did end up with a really good data set. When I looked last night, we had over 90 people, 90 surveys. We might have more now. I can only do that at work, so I have to run into the office because it's my professional SurveyMonkey is actually on my computer at work. So I'm going to run to campus this afternoon and pull that data down into Excel, and then I'll clean it up a little bit, make sure it's really clean and that you can see the variables and all that, okay? So then I'll be posting that Excel file this afternoon, okay? So you'll have it. But I wanted to take a chance or take a moment to just talk about some possible hypotheses that people might lay out for this project. So you'll remember that we asked them, and I had like a nightmare about the survey, like 2 days after we posted it, because I was like, crap, I should have done. We asked whether they had the 5 sessions or more, and then we asked them what their knowledge was. For the knowledge, I should have made that continuous. I should have made that like on a Likert scale, because then we would have had some continuous data for their knowledge from low to high. But I didn't do it. I just put yes or no. So I messed up. And you know, in the real world, when you're doing research, you would be doing a little pilot test, and you'd be getting some people to take your survey on the pilot test, and then they'd give you feedback saying like, gosh, I really wish that, you know, I didn't have to just say, yes, I have good knowledge, or no, I don't. I wish it would have been on a continuum. And then I probably would have changed that, but I didn't. So had a little nightmare about that. I'm like, well, too late now. But anyway, so remember, if we're going to look for relationships, so if I wanted to see if there was a relationship between 2 variables, so let's map out what are our variables. So everybody kind of, what are our variables? What variables are we looking at in the survey? Anyone just shout it out. Rachel?
Well, men and women, and then
Okay, so one is gender, right?
and then education on.
Okay, so sexuality, education, and I'm just gonna say, call that SE. What else? Jordan, what's another one?
Responsibility level.
Okay, so let's call that, you're talking about like the barrier, the contraception, and
How
so let's call,
being responsible.
yeah, so how responsible are they for birth control? Or, yeah, so I guess I can call that responsibility. Okay, that's probably what they call it in the, is that what they call it on the scale itself? Jordan? Is that what they're calling it, responsibility? On that brief sexual, I don't know, I don't remember. They had names for each of the scales.
Yeah, I think
Okay.
it was sexual attitude. Sexuality.
Yeah, so that was part of it. The responsibility was part of the sexual attitude. So it was their attitudes towards their responsibility in birth control and barrier protection, right?
Yeah.
That was one of their attitude scales. What was the other attitude scale? Anyone remember what the other attitude scale was?
Was it permissiveness?
Yes, permissiveness. And then what else? We had one more demographic thing.
We had
Rachel
age.
Rummage?
Age.
age. And then we had one more thing about sexuality
I was-
education. We had knowledge, right?
Yes.
Okay, was that it? I think that was it.
No.
Okay, so if you look on the chat, I put the variables there. So so gender, what level of data is that?
Nominal.
Very good. What else is nominal?
Age.
Now, remember, nominal is just like categories. So nominal could be age. Like, have you ever done a survey where you do your age is between, 18 and 20? Then that would just be a category, right? Versus if somebody actually says, my age is 19. So is age continuous? Like, is there an equal distance between 18 and 19 and then 19 and 20?
Yes.
Yeah, so that's continuous. That's a continuous variable. So age is continuous. Remember, the nominal is just categories, men, women. And then sexuality education. Yes, I had 5 sessions. No, I didn't have 5 sessions. That's just nominal, right? Knowledge. Yes, I have good knowledge. No, I don't have good knowledge. Okay, that's just nominal. So those are our nominal variables. Those are just ways we're going to divide the group. So we could look at the difference between those that have good knowledge and those that, from their opinion, in their own opinion, I have good knowledge, or like, I really don't have that great of knowledge. Is there a difference between those two on permissiveness or on responsibility? Okay, so remember, we're going to use the nominal variables just to divide our sample up to do some analysis on them. Okay, if I want to look at correlation, I can only use continuous variables. So if you're going to look for relationships, you cannot use gender, knowledge, or sexuality education, because those are only nominal variables. They will not work for a correlation. Okay, because a correlation is looking at continuous data and it's comparing it. Do those variables change at the same rate or in the same direction? Is there a positive correlation or is there a negative correlation, right? Positive or negative. Okay, so we can't use nominal data for a correlation. So if you wanted to do a correlation, you could use the only descriptive piece of data you could use is age, because it is continuous. So I could see if there's a correlation between age and permissiveness or age and responsibility. But that's about the only correlation or relationship hypothesis that I could make. Okay? Or I could do responsibility and permissiveness. I could say people that are more responsible are less permissive. I could say my hypothesis is that there'll be a negative or indirect correlation between responsibility and permissiveness. Then I just run a correlation between those two variables and I see, was there a strong negative correlation? Was it significant? Could I even do a regression on it? Okay, so remember, if you write a hypothesis that's about relationship, you can only use continuous data. So the only data you can use is responsibility, permissiveness, and age. Those are that's our only data that's continuous. Okay, gender, education, and knowledge are all nominal, categorical variables. Okay, so if you decide to do relationship, make sure you're doing something between these three, or, age to permissiveness, or age to responsibility, or responsibility to permissiveness. That would be a reasonable relationship hypothesis. Okay, if you want to do something around differences, okay, then you would divide your group up by one of the nominal variables, right? You would divide it up between males and females. You would divide it up between those that had good sexuality education and those that didn't. You would divide it up between those who feel like they have knowledge versus those that feel like they don't have knowledge. Okay? So I haven't seen the data yet, so it'll be interesting. Like, say on this knowledge, let's say that 90% of the people say, I have good knowledge. That might not be a good one for us to use, because you're going to have 90% of the data on one side and only 10% on the other side. And that's a really big difference in variability. Okay, so if you don't have at least, like, what do we need in our groups, like to do differences? What do we need in our groups for that kind of inferential test? How many participants should be in each group?
Shouldn't it be like about the same?
It should be about the same. If you have a little bit of difference, it's okay, but what's the minimum number?
Is it 15?
15 to 30, 15 to 30 in each group. Okay, so if you don't, I would say if you don't have at least 15 to 30 in one of the groups, like if you don't have at least 15 to 30 men or 15 to 30 women, like if there's a big differentiation, let's say you have 82 men and 16 women, it's going to be hard to compare by gender. There's not enough women for us to really tell. Now, I'm pretty sure I'm hoping we'll have a variation. I'm hoping it won't be all women or all men. Okay, I'm hoping there'll be some men and some women, and but it's okay if there's like 70 women and 30 men. As long as you have like 30 in the groups, you can still do some comparison. I mean, you can still look at some differences. Okay, but we're going to divide them up by gender or by whether they had sexuality education or not, or by what their knowledge is. But just make sure you have enough people in one of those groups to be able to separate them. Okay, make sense?
I have a question.
Yes.
So say we had like the 70-30. So we would use all 30 of the one gender, and would we randomly select 30 of the other one, or
We would
no?
use all 70.
Okay.
And we could do, since we have two separate groups, we could use the t-test with that that doesn't assume equal variance.
Okay.
You know, mostly we've been using the t-test that assumes equal variance, right? Two groups assuming equal variance. Well, if you had 30 and 70, you might want to try using the one that does not assume equal variance, since there's a really big difference in size. It's still not that huge. I mean, I've seen where they compare 15 people to 1,000 people, right? That's a huge differentiation in variance. Okay. Okay, so is that making sense? Okay, so if you choose to see if there's a difference, you know, you could do a null hypothesis. You could say, I don't think there's any difference between men and women on responsibility. Okay, and then you would just take the scores, and what will happen is you're going to see a total responsibility score and a total permissiveness score. I'll add up all of the, so basically we had 5 items for responsibility, and you're going to use the total score, right, for the responsibility score. And then there's 5 items for permissiveness, and then those will all be added for a total permissiveness score. Okay, so so you would say, I don't think there's going to be difference between men and women on permissiveness. So what would you run? Like if you had men and women and you were looking at permissiveness, what kind of inferential test would you run? Be brave. It's okay to be wrong.
Would that be an independent t-test?
Very good. So 2 groups, one measure, right? Two separate groups, independent, one measure, permissiveness. Okay, so you'd run an independent t-test to see if there's a difference between men and women on permissiveness. And since I said there'll be no difference, I don't think there's any difference between men and women on permissiveness. Would I look at a one-tailed or a two-tailed? Right, two-tailed tests, I'd say there's no difference. I look at the two-tailed test results. Okay? So what you have to determine is, out of all of these different variables, you need to decide what your design's going to be. Okay, what inferential test or tests are you going to perform on the data? Okay, you can have more than one hypothesis. You could do a correlation and a t-test. You could see if there's any relationship between some of the variables, and then you can see if there's any difference between, you know, gender, or between whether someone had sexuality education or not. Okay, or you could run two separate t-tests. You could look at gender and sexuality education, or sexuality education and knowledge. Okay, the key is you want to make sure you state a hypothesis either as a null or a directional, and you want to run the right inferential test. And then you want to read that test correctly. You want to make sure you look at the results and get the right answer. Okay? Because what's going to happen is when you turn your paper in, whatever your hypothesis is, I'm going to go and run those stats, and I'm going to look at it. Okay? And if you get the wrong results, or you run the wrong test, then you won't get all the points. You know, if you run the wrong test, but you still interpreted it right, I'll give you some credit for interpreting it right, but you're gonna get points off because you ran the wrong test. So if you say, I think there's a relationship between age and permissiveness, and then you do a t-test, that's the wrong test. If you're saying relationship, t-test is not about relationship. Correlation is about relationship. So if you say, I think there's a relationship between age and permissiveness, sexual permissiveness, and then you run a t-test, I'll take points off. But if you interpret the t-test correctly, then, you know, then I'll probably give you some points. Okay? Questions? So just make sure you're better off doing, you're better off doing something you feel confident with than trying to do something really complicated to get more points, and then you end up doing it wrong. Rachel, question.
So if we did age and permissiveness and we did a correlation, would you want us to do a regression too?
Depends on what your correlation ends up at, right? Say the correlation was really crummy, then you could just say, this was a very low correlation. I do not see any need to perform a regression, and we really couldn't predict someone's permissiveness based on their age. There's no correlation here. But if there's a really high correlation, then you could say, hey, there's a really high positive correlation, or there's a really high negative or indirect correlation. I want to go ahead and perform a regression. And then you perform the regression and see if it's significant. And then you could say, this would be the regression equation. I could predict how permissive someone's going to be based on their age.
Okay.
And you would state state the regression equation. And then you might even do an example. So you might say, for example, if someone's 18, this would be their permissiveness score, versus if somebody's 30, this would be their permissiveness score. Okay, and that would be in your discussion. And then your conclusion, if it was significant and you could do a regression and regression equation, you would say like, hey, I accept my hypothesis. Age and permissiveness were whatever, highly positively correlated or highly negative, indirectly correlated, whatever it ends up. You just have to be willing to interpret, though, or you have to be able to interpret that correctly. And remember, you guys, the results we get from this was done quick and dirty. I don't even know how valid it is. So don't be telling people like, hey, there's a correlation between age and how permissive you are, because I don't know that that's really true. We're just using this data for the sake of getting some good actual data, and then developing some hypothesis around it, and then applying some inferential tests, and then interpreting those. I just want to see that you can do that. Okay, make sense? Okay, so that's what you're demonstrating. You're demonstrating that you can take an Excel file of data, you can apply inferential statistical test, and then you can report it in a way that's understandable, right? So you're doing an introduction, you're doing a good title using your variables and your population. You're doing an introduction talking about those variables and maybe citing some sources, stating your one or more hypotheses. Then you're going to talk about the methods, what we did. We developed the survey. We used that brief sexual attitude survey, 2 of the scales off of that. We put the survey out on SurveyMonkey, blah, blah, blah. You're going to say what statistical analysis, what inferential tests you were going to run in your results. You're going to state the results of your inferential tests. So you're going to have your regression. You're going to maybe have the output of that. I mean, your correlation, maybe the output of that regression. You might have your, if you do a t-test or an ANOVA, I guess you can't do an ANOVA. That's the other thing, is I was like, because of what we did, we didn't find anything that would divide them into 3 groups. So,
Well, that was
pardon?
my question. I was gonna ask if you could do an ANOVA with like age, gender, and sexual permissiveness, or would that not be possible?
Well, you have to do, if you're going to use a variable that is nominal, then you're going to have to do a 2-way ANOVA, and we haven't really talked about that, about doing a 2-way ANOVA. So we've only talked about doing simple 1-way ANOVAs, and with the 1-way ANOVAs, you have to be using a continuous variable. You would have to divide it into 3 groups somehow. And that's another reason I was kicking myself for not saying like maybe high, medium, low on the knowledge. Then we would have had 3 groups, right? That we could have put it into an ANOVA. So the bad thing about the ANOVA in Excel is that you can't do a post hoc anyway. So all you can do is say like, yeah, there's a difference somewhere. So for this project, you're going to be doing either t-tests or correlation and regression. Okay, so that's up to you how you do it. You just got to make sure that you interpret it correctly. So then you put, then in the results, you're putting your results. For the t-test, you're going to put your means with the error, the plus or minus your error rating. Okay, and then you should use standard error, because you're comparing means. So use the standard error, not the standard deviation. And then you're gonna tell what the results of your t-test was. What was the probability level? What was the calculated t? So that's all in the example. And then you would talk about it in your discussion. You could cite any research that saw the same outcomes that you did. And then the conclusion is just saying, I accept my hypothesis or I don't accept my hypothesis. Okay? So that's what you're going to be doing. Hopefully, maybe you got started on it this weekend, but if not, you've got until Thursday to get that done. We're not going to meet tomorrow or Wednesday. I just want to give you time to work on that paper. So set time out. Don't just be like, oh, I'll do it later. I'll do it later. You've got to get started on this, because you don't want to be there on Thursday, like trying to get your final done, trying to get your paper done, being all, busy. So you gotta use your time wisely, okay? Because you need to be studying for your final as well as getting this paper done, okay? I am here for you. Please ask me questions. I cannot tell you what test to use. If you say, if this is my hypothesis, should I use this test? I can't tell you. I can just say, look at the words you looked in that you used in the hypothesis. Did you use relationship or differences? If you use relationship, you're going to always use a correlation and possibly a regression. If you said differences or higher or lower, then you're going to be using a t-test, right? And you've got to know whether to use an independent t-test or a dependent t-test. So those are the things I'm going to be looking for. Okay? But I am here to answer questions, and certainly, definitely about the final if there's any concepts you're still struggling with. Okay? Your paper, you just post it to Blackboard on the, there's a place to post it. So just attach the file on Blackboard. Questions? Okay. You guys can do this. I have faith in you. Okay. Reach out if you need help. I think I gave you till Thursday to get those extra homeworks done too. If you want to get the extra credit on the final, you got to do that sheet that that's under the final on Blackboard for 2 points, as well as the evaluation. All you need to do is email me a copy of the screen. You can screenshot the screen when you finish. You know, when you finish your evaluation, it just says you're done. Just email me that screen and you'll get a extra 2 points on the 2 percentage points on the final. Okay. Okay, well, if there's nothing else, I'll stay on in case somebody has any questions. But if not, I won't see you till Thursday. We are going to meet on Thursday. Just briefly, I just want to check in with you guys, see if you have any final questions or if you need anything. So I'll be on Thursday at 10:30. If you feel good and you feel like everything's going well, you don't need to show up. If you need help, please show up. Okay, so I will be on Thursday at 10:30. I really want to thank you guys again for all the effort that you put in, for showing up, for doing your best. And I enjoyed being in class with you, seeing your beautiful faces on the screen. I wish we could be in person, but at least I do get to see you. I'd rather do this than it just be completely asynchronous where I don't ever see you. So I hope the lectures were helpful to you. I would love input to see what might have made it could make it better. I'm still learning and growing as a teacher. And since I'm going to be teaching synchronous in the fall, and then I'm going to be doing a combination, you know, synchronous, and there's going to be some people that have to be asynchronous. I just want to do a good job in my class in the fall. So any input you could give me is really valued. If you need help with anything with the program, whether it's, you know, advising or you're struggling with getting in the right classes or whatever, please reach out to me or your advisor. If you don't know who your advisor is, I can let you know who that person is, but please get help if you need help with that, because we really want to help you keep moving forward in your degree program so you can get finished and get out there contributing and working and or going to grad school or whatever you plan to do. Okay, so thanks again, and I'll either see you on Thursday morning or I'll see you in the fall.
I have a really quick question.
Sure.
So I started working on the paper and kind of drafting out like a hypothesis and an introduction. And I was thinking I was going to do a correlation between age and responsibility and see if that, and then when I am like drafting that out on Excel, am I doing like a column of age and then a column of like responsibility, like yes, no, like yes or no, not responsible, or like how am I doing that?
Okay, so
Is that-
remember responsibility is a continuous variable because it's that variable where we ask 5 questions.
Yeah.
And so we're going to get, so you can do age and responsibility. So in Excel, remember for correlation, those 2 columns of data have to be right next to each other because you
Okay.
just pull the whole column.
Right.
I mean, you pull the whole set, the 2. So those have to be right next to each other. So when you get the data, they may not be next to each other. So
Right.
you've got to pull them into either a different, you know, a different screen or whatever, or somewhere off to the side and put them right next to each other.
Okay, cool. And then I just want to make sure I'm running the right tests. So tests I could run for that would be just like the correlation, like go to data analysis and click the correlation and have it pop up with everything.
Mhm.
Is that really like the main one that I would be doing? And then could I do like a t-test too to see if there's or a difference? No, because then I'd have to switch variables. Never mind.
Well, I mean, if you wanted to look at a difference, you would have to divide your group up somehow.
Okay.
You know, so like we talked about, you could divide by gender and say, is there a gender difference on responsibility? Is there any difference between men and women in their responsibility level?
Okay.
You know, and then you could run a t-test on that, or you could divide it by their knowledge level. Is there a difference in responsibility for those that feel like they have good knowledge versus people that feel like they don't have, that they have poor knowledge?
Okay. And
So
is
then
it
you would,
okay-
just like on the other things we did, you would have to sort by their knowledge level. So you'd have the yes, good knowledge, no, not good knowledge. Okay. And then you'd have your permissiveness score or your responsibility score, and you would pull, you know, then you would pull the yes scores and then the no scores, right? And compare those, just like we've done in the other homework.
Right. Okay. Cool. Cool. That's very helpful. Because I was a little bit confused over like the weekend when I started working on it. I was like, how am I going to do this? And I was looking at the sample and they did like the mean, median, and mode. And I was like, but that doesn't make sense for our data as much sense.
Well, I mean, you can still run descriptive statistics on it, but you have to run an inferential test. It's
Okay.
not just the descriptive statistics, right? That just tells you about your group.
Yeah.
You know, that just tells you, hey, what percentage were male and what percentage were female, which you might want to tell us about, you know, in the results.
Yeah.
Or it might tell you, oh, here's the average responsibility score, or here's the average permissiveness score. But that's just describing the group. That's not anything you're writing a hypothesis on, right? You've got to write a hypothesis either on a relationship or a difference.
Okay. Okay, perfect. Thank you so much. That's very
Okay.
helpful.
You bet.
Okay, bye.
Okay, see you later. Bye-bye.